Hello everyone, this is the presentation 4 and topic 3 for CS 520. Find prime factors of an integer number. My name is Xuanyu and my Drexel email is right here. So let's get started. Overviews of what we're trying to do here. Firstly, we want to take a look at the steps of how to find the prime factors of an integer number. And secondly, we want to show an example of how to do that. And thirdly, we will take a look at the pseudocode to show how this works exactly. And lastly, we will do the big O runtime analysis. So what we have here is an integer n, and what we're trying to do is to find all the prime factors of the integer n. The correct steps are, firstly, if the integer n is even or divisible by 2, we print a 2 and we divide it by another 2, and we keep printing 2 once it is divided by 2. And secondly, if this integer number n is bigger than 1 and n is not even, it cannot be divided by 2, so the n is a odd number right now. We divide the integer n by odd number I, and we print the I. The odd number I starts from 3, so we keep dividing n by 3 until n is not divisible by 3. So, and after that, we divide n by next odd number I. So the next number after 3 is 5, and it's 7, and so on and so on. And once we get our I is bigger than square root of n, we end the process. So what it means is that, like for example, we have a square root of n equals to 4. Let's say 4, and we start dividing the n from 3, and 3 is smaller than 4, so we keep doing that, and we divide it by 5, and it's bigger than the square root of n, which is 4, so we end the process from there. And the last step is if the integer n is bigger than 2 and there's no more factor smaller than the square root of n, we print the n as a prime factor. So n is what we have finally after all of that. And if there's no more factors which is smaller than the square root of n, we print the n as our last prime factor. So let's take a look at the example here. We have our integer number n, 1,548. So 1548 divided by 2. First we divide by 2, and it is divisible by 2. So we got a 774 here, and we print a 2. And we keep dividing by 2. It's still divisible by 2, so it's an even number. So we got 387 here. And we print another 2 here. So 387 is not even, it is an odd number. So after this, we divided the 387 by 3, and we got a 129. It is divisible by 3, so we print the 3 in the list, and we keep dividing by 3, and we still have a 43. The 129 is divisible by 3, so we print another 3. And after that, we have a 43, and 43 is not divisible by 3, and we keep dividing it by the next odd number, which is 5. It's still not divisible, and the next we are supposed to divide it by the next odd number, which is 7, but what we got here is the square root of 43. So we have here is square root of 43, which is 6.56. So we hit the square root of 43 because after we divided by we're trying to divide it by 5, it was not successful because it was not divisible by 5, and when we tried to divide it by 7, it is bigger than the square root of 33. So we stop the process and print 43 as our last prime factor. So the prime factors of all of this is the list of 2, 2, 3, 3, and 43. These are the correct steps of how to find the prime factors of an integer number. And let's take a look at the pseudocode here. So as I said, the first we want to do is to divide n by 2, and if it's divisible, so there's no no remainder, we can see that the n is the even number and it's divisible by 2. So we print a 2 in our prime factors list, and we keep divided by 2 by another 2. As long as it's an even number, we just keep iterating and keep doing this loop, and until we have the odd number. So once we have an odd number, we start dividing this number by 3, which is I starts from 3, and I needs to be smaller than the square root of n, and I equals to I plus 2. So this is the next odd number after an odd number. For example, we have a 5 equals to 3 plus 2, so 3, 5, and 7, so on and so on. And as long as the n is divisible by the odd number I, we print the I, and we keep doing that. And so we have a for loop right here. So what it says is as long as we can't divide it by a odd number, we keep doing that. But once I is bigger than the square root of n, we end the whole process, because I has to be smaller or equal to the square root of n. That's what makes this while loop happen. And finally, if the n is bigger than 2 and there's no primary and there's no prime number, and finally, once if n is bigger than 2 and there's no more factor smaller than the square root of n, we print n as our prime factor. And lastly, we want to do the big O analysis. So we take the same number 1548, and the square root of 1548, which is the big O of n, is 39.34. And what we actually have in the algorithm is 5 times until we find all the prime factors of the integer. So we have a big O, as this includes the actual times t of n. So we have a big O bigger than t of n, so which is 39 and 34, and 5 times actually. So that's the big O we have here. Okay, that's it. This is the reference I have. Thank you for watching. Hope you can learn from this presentation. Thank you. Bye.